So the central idea in our last video is that when you make your own class, your own user-defined object, it can hold on to multiple attributes. And those attributes could be all types of different things. They could be ints, doubles, booleans, strings. It could even be other user-defined attributes in classes. So in this one here, we're going to look more at the actions that these user-defined objects can do. We call these the methods. So once again, you'll notice that I have several classes over here in addition to our main. And in our main method, we're now going to put into action some of those different user-defined methods. Okay, so one of the things we're going to learn about is that methods are called through objects of the class. And so you might remember in our first video, we learned that to create an object from the class, you first have to declare something of that type. It's like declaring a primitive variable, but this is not an int or a double. I'm declaring a print test, and I've named it test1. So what is a print test? Well, over here you'll see that I made a class called printtest.java, and a print test, it doesn't really have any attributes, but it has a lot of actions. These are the methods that belong to this class. And way down here, I put a default, what we call no argument constructor. We'll learn later in the year, I didn't even actually have to put that there. Java would have provided it for me by default. So sometimes it's called a default constructor. And I can use that to build objects from this class. And to do so, I won't be required to provide any types of parameters, okay? Actual parameters or arguments, they're sometimes referred to as. Now, once I've created a print test object, it won't really have any attributes associated with it because I didn't provide any instance variables here, any variables that belong to this class, but I've put instead a lot of methods. Okay, these methods are all the things that it can do. So for example, if I call this method print test alpha, then it will simply print the letter A. Okay, and here's how I did that over here. So it was kind of a two-step process. The first step was I had to create an object from the class, and I called that object test1. Test1 is a print test object type, okay? Now, with that object, which is sometimes called a reference to this class, I can use that object to refer to the attributes of the class, okay, and the methods of the class. And so today I'm referring to some of the methods from that class. So the first method I referred to was print test alpha, and the second method I referred to is print test beta. It says that the dot operator is used along with the object name to call non-static methods. So that period right there, that's an operator in Java. So, okay, it's sometimes referred to as like the access point. So the way this is read is that when you call this unfamiliar method, this is not something that was put into the original Java language. It's just something I made up. So the computer doesn't recognize it. It doesn't know what to do. Okay, it doesn't know what print test alpha is. So through that access point, it is acknowledging the fact then that if it were to go look in this type of objects class, it hopes to find further instructions for what to do. So it checks what type of object test1 is. Okay, so test1 is a print test. So then it refers to the print test class and it looks for a method by that name and it finds it. And everything matches up. This method doesn't require any more information, which we would call parameters. So it just runs it as is and it prints the letter A. And that's exactly what we see happening over here with that letter A. And a very similar thing took place to print the letter B. It went and looked in that class. It found the method called print test beta, and it acted as it was instructed to do. So void methods don't have return values, and therefore cannot be called as part of an expression. So an expression refers to, for example, like a math expression. So any combination of like an arithmetic operator. Also, a print statement is a type of expression. So what you don't want to try to do is, for example, here I'm trying to print my method call, okay? You can't do that. If a method has been labeled as a type void, okay, that means that the method doesn't have a return associated with. In other words, it's like saying it doesn't provide an answer. So as a result, this method, it might do something, but it doesn't give back anything. Since it doesn't return or give back anything, we can't use it in connection with some other thing. So I can't use it in connection with a print statement. I can't use it in connection with an addition. I can't try to add 7 to it because there is no like result provided. So either of these two lines of code that I have here are going to result in some sort of compile error. And let's see what it tells us over here. In both cases, it says void type not allowed here. So what you have to remember is that anytime you have a voided return method, you're not allowed to put it into an expression, either a mathematical expression or a print expression, or even like an assignment expression. So even if I got rid of the +7 here, you know, the method itself doesn't create an integer. It also doesn't create a string. It prints a string, but it doesn't return one. So you're not allowed to use it as part of an expression. Using a null reference to call a method, okay, or access an instance variable causes a null pointer exception to be thrown. If I were to just declare a print test and call it test2, but notice what I didn't do. I didn't go on to initialize it. I didn't say new print test. I simply declared the existence of that variable type. If I then tried to call a print test method, that wouldn't work, okay? And neither would this. There's a nice little video in CS Awesome on this you might like to watch, where the instructor shows some different null pointer exceptions, okay? So these are what we refer to as, the variable here. It says that it wasn't initialized. If we try turning this one off, see what this error message tells us for line 72. These are things that we want to avoid. So this is a null pointer exception. You can only use this access point, okay, that we see right here, okay, the dot operator, to call methods on objects that have been initialized. So this object here, test2, I declared its existence, but I never initialized it, so I can't use it to call any of the methods from the class. You also could not refer to any of its attributes. We haven't tried that yet, but we'll look at that coming up. A method for, a method signature for a method with parameters consists of the method name and the ordered list of parameter types. So if you look at all my print test methods, none of these had any parameters. And if you'd like, take a minute and try out some of the other ones I put in there: gamma, delta, epsilon, zeta. Okay. But moving on, let's try some of these math functions I put in here. Now, these math functions are a little bit different. They're still voided in their return, but these have parameters associated with them. So if you look at my math functions, they want more information from the user. What they're saying is if you want to use this method, you have to give me 2 integers. Remember, those are called formal parameters here, where they're defined. And then when you use that method, you're going to provide actual parameters. You're going to provide 2 actual ints to use that method. Copies of your int values would be used to set up this x and this y, these formal parameters, and then they would become the values seen within that print statement. So if you notice right here, I've made a math functions called runner, and I've called function 2 and function 3. So let's see what those functions do. Function 2 takes the second number, y, and subtracts from it the first number, x, in that order. Function 3 takes the number and multiplies it by 1 more than itself. Okay, so it's going to depend on what numbers you say to use. Those print statements I showed you earlier in my print test, they always printed A, they always printed B. the user didn't get to define those methods in terms of what they're going to do. Here, you have some input. You don't get to choose the math function, but you get to choose the numbers. Okay, so these are parameters. These are sometimes called arguments. Remember how this is going to work. This should take 7 minus 3. We should see 4 here. This should take 8 times 1 plus 8. 8 times 9, we should see 72. So we didn't get to choose earlier the A and the B, but here with these functions, we get to choose what they're going to do. To some extent, we get to choose the numbers that are copied and used in the evaluation. Now, I get to choose those numbers. It's not even like that I get to, it's more like that I have to. So if you tried running function 2 and 3 and you didn't follow the rules, so look at how I'm violating the rules here. Remember, function 2 wanted 2 integers so it could subtract them. Function 3 wanted 1 number to use in a multiplication problem. So here I tried to give 1 number to function 2. It's going to reject that. Later, I tried to give 2 numbers to function 3. It's going to reject that. You can only give 1 number to function 3. In the third example, that was actually, I know it might look like a comma. It's actually a period I put there. That's a decimal. Remember, the function 3 was expecting an integer. So if I tried to give it a double, I have violated its parameter list. If the parameter list is saying, give me 1 int value, and you try to give it a double, well, we've seen before, you can't give a double to an int. Now, you can give an int to a double. That would actually work. So if you went over there and changed the parameter type to say double, and then the user put an int in, that actually would be accepted. But none of these work. Same thing here. Like imagine you tried taking out these numbers. Remember how the print test function and they were just blank? That isn't going to work either. So if we tried to run these functions with an empty, what we call like a no argument parameter list, okay, then sometimes we call this like parameter lists. That isn't going to work either. It worked with the print test, but that's because whoever authored the print test class, in this case me, I chose to make these methods parameterless. So like my print test alpha wasn't requiring anything. Okay, so like I said, this is often called a parameter list. Sorry, parameterless method. Okay, over here in our math functions, these were requiring parameters. And if I violated what was expected, then the function wouldn't run. Okay, so that's why I was getting these error messages down here. Okay, let's go ahead and comment those back so that we don't see that error again. Methods are said to be overloaded when there are multiple methods with the same name but a different signature. Okay, the signature is everything you see in the definition of that method. So right here, this is the signature of that add method. It's public. We're going to learn that there's other choices there in the future. Its return is void. So it doesn't actually, it prints an answer, but it doesn't actually return that answer. And we're going to see the difference coming up in a minute. And then it requires its name is add, and it requires an int followed by an int. That's its signature. Okay. So this whole line of code that you see right here is called the signature of the method. And this method looks really similar, but it has a slightly different signature because you can give it 3 int values. And it will know what to do, okay? Because right here, you're basically saying, I would like to use the add method of the runner class that is expecting 2 integers. Here you're saying, I would like to use the add method of the runner class that is expecting 3 integers. In both cases, the code was instructed to print the sum of those numbers. Now, what if somebody over here said, I would like to make another call. I'm going to say runner, and I'm going to say dot add, and I'm going to put in 4 numbers. That person is saying, I would like to use the add method of the runner class that adds together 4 numbers. There is no such method. When I wrote the math functions class, which is the type that runner is, I didn't write a method expecting 4 integers. So there is no connection now That's why I'm getting this strange error message over here. It says no suitable method found. It couldn't go into, okay, remember runner is a math function. So it followed the path that I specified. It went into the math functions class and it looked for an add method that was expecting 4 ints. It had a parameter list that was looking for 4 ints. It didn't find one by that name add. And so that's why it told me no suitable method. Okay. But it did find one for 2 numbers and it found a different one for 3. That's called an overload. All right. There's another type of method that isn't void. They're called return methods. They return a value that is the same type, okay, as the return type in the signature. All right. And if you want to use that, you can store it in a variable, or you can print it, or you could use it within an expression. So in my third class that I wrote called return methods, I put in several methods here called method A, times 2, method C, method D. Some are parameterless, some are expecting parameters, but these methods all have a return type. Okay. The first 3 return a type int. Notice how you don't see the word void now. We did not void the return of these methods. Okay. We gave a return. That means that this method has to terminate with a returned value. And then that returned value, which is clearly specified by the word return, okay, has to be of matching type. So if this says int, this must be an int. If this says Boolean, then this must be a Boolean. And here I'm using a Boolean operator called greater than, which I haven't taught that to you formally yet, but you can kind of figure out what it's probably going to do there. It's going to assess this operator as either true or false, and then it's going to make a return based on that. So it's going to evaluate it. It's going to say num1 is bigger than num2, true, or if num1 is not larger than num2, it will say false, and that would become the return of that method. Notice how we're not printing from these return methods. Okay, it's a little bit different. These are going to return a number. On the user side, when you get that number returned to you, you could choose to print it. Do you remember earlier what happened when I tried to print a voided method? I got an error message. This is going to allow me to print the result of method A. Okay, the difference is method A is a return method that returns 10. So therefore, if you were to run the method from the return methods class called method A, which doesn't expect any parameters, but has been programmed to return the value 10, you could then take that number and put it into a print statement. You could do other things with that number 10 too also. You could initialize an int with it. You could use it in a math expression, okay? Meaning like I could add 5 to it. Now the print statement would print 15. You can think of the return method essentially as like being replaced. What I have highlighted right there is going to be replaced by an int. In this case, it's going to be replaced by the int 10 because that's what that method was told to do. Okay, what was the times 2 method told to do? You can probably guess. And very often we try to write our methods with very descriptive names. Often as a programmer, you don't look at somebody's source code. You look at a library that just contains their method names and perhaps a short description of what those methods do. And you look at their signatures so you know how to use them. You know their return types, you know their names, you know their parameter list. So what's required of you to use those methods. You don't actually look at their code to see how they did it. All you do is look at their method and then you kind of figure it out from there, like their signature, because that's like all that you really need to know. All right. And we're going to see more of that in our next lesson with strings. All right. But this times 2 method here, okay, let's go see what it says. All right. And like I said, as you would probably guess, sorry, I went to the wrong one. The times 2 method just doubles the integer that you give it. So in my code here, I gave it the number 10, but it actually printed 20 because it multiplied it by 2. Now, I was using that number to initialize an int. And remember, again, earlier today, this would have been an error if we go back to our void methods. Remember earlier with our void method up here, when I tried to initialize an int, or when I tried to print, a voided return method, I got an error message. What's making this not, an error is that this method was not voided. This was a return method, and its return type happened to be int. So therefore, I could use it to initialize an int. If I was trying to initialize a Boolean, I'd get an error message. I can't initialize a Boolean with an int. Okay, I could initialize a double. That would actually be legal, or I could initialize an int. Here I called method D with a 3 and a 5, and here I called method D and I used it to initialize a Boolean. So if you look at method D, it was a little interesting. Method D first called method A, put it in a num1, which remember that's always 10. This one called method C, which added these two numbers that the user provided, and then it figured out which one was bigger. Okay, so 8 plus 7 is 15. 15 is greater than 10. That's why this printed true, or sorry, false. 10 is not greater than 15. This one did 3 plus 5, which was 8. 10 was greater than 8. That's why that one printed true. I encourage you to, I didn't call all the methods that I created. So, you've got this Replit code available to you. I encourage you to come over and experiment. Try making your own object from these classes. So maybe like print test, my test equals new print test. And then, try calling some methods from the print test, see what happens. And study what happens in some of these weird ones here that I have kind of jumping around. Maybe look at my math functions, maybe try some of the return methods. But, I encourage you to you have this code available to you, experiment a little and see what happens.